Okay, having sort of made some progress on when and if we should try linear regression, I want to kind of go through a quick example. And we'll get to some detail in it, and some detail we'll have to save. So the example, I want to kind of go back over our previous example. It would be pretty helpful. Oops, not that one. It would be pretty helpful if you had your regression workout. Where'd it go? All nice and organized, like me. This page here. So we went through this regression workout, if you will, a couple classes ago, and we calculated a coefficient by hand. Pretty laborious, but you at least see where it comes from. And what I want to do now is kind of go back through that, a full example of regression. Just take us a few minutes here, ping on a couple things, and save a couple questions for later. So here's our stuff. We got grades versus hours studied. So the first thing we want to do, once we've determined, yep, those are both quantitative, let's look at the scatter plot. Here's the scatter plot. Is it feasible to continue with a linear regression? Yeah, I'd say so. Looks linear enough. Let's do it. Is it a strong correlation? Well, not as strong as in the last video we saw a 0.9, and this doesn't look as strong as that. We also saw something close to 0. And this looks better than that. So we might expect a coefficient somewhere in between that. And in fact, what we discovered is that this had a coefficient of 0.62. So how are we going to get that? In general, what we're going to do is go to our calculator, enter all that data in as we did. I don't know how well you can see that on the video. But we did this on our calculators. So we were doing our linreg, boom, boom, boom. And the linear regression gave us all these values. So I'm going to move the calculator aside and write those down. You should redo this on your calculator. When we did the linreg on the calculator, we found that A was equal to, I'm going to round them, 2.70, B was equal to 70.0, R squared, and I'll mention why they give you R squared of 0.38, and R, as we did so laboriously and caretakingly, 0.62. That's our strength of at least what we're currently calling the strength of our correlation. Not too bad. We'll see stronger ones. So what we do from this is we come to, I think, what the form of it is. This is a y equals ax plus b. So this is telling us that y, and that's right on the calculator, y is equal to 2.70x plus 70.0. Or more importantly for us, since we were comparing grades, your grade is equal to 2.70 times your hour plus 70. We put a little hat over the grade so that what we're acknowledging when we do that is that this is a predictive formula. That is, we're predicting grades given a particular number of hours studied. So for example, if we were to study for 10 hours, chow through the math in my head, chow, 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 do it yourself, we would expect to get a 97 according to this model. This is a mathematical model. We're going to use it to predict. Okay, so as we'll see, I'll do another video, not every data point. It's not going to work for every data point. For example, if we put in 8, ooh, that's a little harder to do in my head, but if we put in 8 hours, we'd expect that's going to be about, what's 8 times 2.7? Let's do it. 8 times 2.7, 21.6. So we expect, our model predicts that for 8 hours studied, I don't know if you can see the calculator, we're going to get a 91.6 for 8 hours of study. Okay, that's a predicted value. If we look at our data set, notice for 8 hours we get a whole bunch of different ranges. Here's 90. Here's our expected, our calculated value right here. Some of them are higher. They have what we will show as a positive residual, some are lower, they have a negative residual. That's what a residual is. Okay, I want to mention one last thing here, and that's this R squared business. And this is going to take care of the variability. And what I mean by that, it's R squared is just, if you took 0.62 and squared it, you'd get 0.38. Why don't you take a second and do that? Because that's all it is, R and R squared. Why would they bother writing R squared? This is why. Because we interpret that, R squared equals, still on, okay, making sure I'm still on the page here. If R squared is equal to 0.38, then we interpret that as 38%. And more specifically, I'll write it out. What it says is 38% of the variability in grades. So 38%, if you look at just this stack here, 38% of the variability in grades can be accounted for by the variability in the hours studied. So I'll write that down. Here's our interpretation of the R squared. We would say 38% of the variability in grades is accounted for by the variation in hours studied. Now, would it be nice if 100% of the variability in grades is accounted for by the variation in hours studied? Sure. That would be a clean and simple world. It's not a clean and simple world. The best we can do here is to say that by statistical analysis, 38% of the variability in grades is accounted for by the variation in hours studied. Does it make sense to study more? Yes. Is it going to guarantee you a certain grade? No. Kind of makes sense if you think about it. Which I really want you to do.